find, okay, for this case, for the conditional probability case, okay? So I forgot to put the bracket inside. Okay, so you know that from the, okay, I draw you again the timeline. Okay, you need to draw the timeline so that you can see it more clearly. So we are interested only for this range, for this period. You are interested on the death probability. So we know that death only happen once. So we assume that the death will happen in from 55 to 56. So it means that it won't happen before that. So the death won't happen before that. So before that, we assume that he must survive. So here, he must survive. And here, the death may happen. Okay, the death may happen. So what is T here? So the T here is equal to 4. 55 minus 51. So 4 here. T is 4. So P51, P51, since the current age is 51, so P51, for the first 4 years, T is equal to 4. So we know that the probability of survive, we calculate the probability of survive because we assume that that person must survive. So at age Q55, so now it becomes 55 until 1, T is equal to 1 here. Or we don't put 1. Okay, 1. So you know that it is only 1. So we are calculating the probability of death. Okay, so at 55, you should put in the bracket or not. So at 51, we should put bracket here because it's still in the select life table. Okay, as I mentioned already in the question B, so starting from age, starting from 57, so starting from here, 54 plus 3, it's 51, sorry. Okay, so now we go to here. Now we go to, okay, so this line, 51. So 51, starting age 54, sorry. Starting age 54 is not in the select life table anymore. He's joined to the ultimate life table. So ultimate life table, so we don't need to put in the bracket. So how to calculate this one? In terms of LX. So P51 4 or 4P51 is LX plus T. So X is 51 plus T over L51. Okay. Actually, 51 plus 4 also in the ultimate life table already because it's starting from age 54. Then, so starting age 54 is joined the ultimate life table. So 51 plus 4 is 55. So now you can put it as L55. Okay, L55. Why I write like this? So you won't get confused. Okay, so for Q is Lx minus Lx plus T over Lx. So Lx is 55 minus Lx plus T is 56 over L55. So now we just have one value for the select life table. So this one we can cancel out. So what's left? L55 minus L56 over L51. So L55, so we can refer here. L55 is 77,000. L56 is 75,000. 77,000 minus 75,000 over. So don't, okay, so over L51 in the bracket is this one, L51 in the bracket. So L51 in the square bracket is 88,000. So you will get 0.0227. Okay. Are you okay so far? So do you have any problems so far? Okay. I hope that you won't get confused anymore for the select left table. Okay, so for C, you have to use UDD, isn't it? UDD Q50 plus 0.25. So for this one, you have fractional each in the select life table. So LX plus T, LX minus. So this is for LX minus LX plus T over LX. Okay, so LX is L50 plus 0.25. So the X is the current age. So the current age is all this, not just the first 50. 50 plus 0.25 minus, so we don't have number at the back, so we know that it is plus 1. So 50 plus 1 plus 0.25, or you can plus 1.25. So over LX. So LX is 50 plus 0.25. So now it becomes, okay, so UDD for LX plus T is LX minus T dx. So T is 0.25, D 50. So for UDD, if you refer back, LX plus T is equal to LX minus T dx. T dx. So LX, so we take X only. So LX, L50 minus T. T is 0.25. T is the fractional 0.25. So dx is D50. So D50. D is number of death. Okay, so minus L51. So we can put it together because select left table, it's starting from the it includes for the first 3 years. So L51 plus 0.25. I put it here. L51 so it becomes we still use the same thing. So L51 plus T is 0.25 D51 over the same thing as Okay, D for 50. So now you have to find the value for dx. So the dx is Lx minus Lx plus 1. So ndx is Lx minus Lx plus n. So we need D50 and D50, D51. So this also have, we need bracket. We need the bracket for the H. Okay, so L50 is, you have to refer to the, so D50 is L50 minus L51. It is 2000. Okay, you have to refer to the table. So D51 is L51 minus L52. It is 3000. Then you plug in L50 is 90,000. So you plug in all the values. So L51 is 88,000. Over blah blah blah, and you will get 0.02514. Okay, so do you have any problem so far? Okay, now we go to question 3. 1, 2. So now we have question 3. All right, question 3. Assume that mortality is described by De Mor's law. So you know that we're using De Mor's law with the maximum age omega equal to 110. So omega is equal to 110, and the force of interest delta is 0.005. Okay, now you have to find 20-year endowment with a death benefit 150,000, and we have survival benefit is 50,000. You know that endowment we have to benefit, so survival benefit is 150,000, and the survival benefit is 50,000 if we survive until 20 years. Okay, so calculate the net single premium for this insurance policy. So how to write the equation? So we have two, we have how to write the endowment. So endowment is A. So X is your metric number. Let's say your metric number is, when you sum up your metric number, it's become 21. For example, I take 21. So 21. So how many years? N is equal to 20. So this is how you write the endowment. So endowment we have term, and also we have pure endowment. So for term insurance, it's for death benefit, and for the pure endowment is for the survival benefit. So we have 150,000 for the term. So we put 1 on the top of each plus 50 for the pure endowment. So how you write the pure endowment? So 1 on the end. Okay, 1 on the end. So you can solve for that question. And then, okay, question 3. We using we using Demon's law. So let's say 21, 20. So for the term, so first we calculate for the term first. So for the term, the boundaries must from 0 to n. Okay. So what must be inside in the integration? Must have Vt, Tpx, mu x plus t. So Vt here is E negative delta t, which is 0.05 t. What is Tpx, mu x plus t? For De Mor's law, so for De Mor's law, the Tpx mu x plus t is 1 over omega minus x. So what is 1 over omega minus x? Is omega is 110 and the x is 20, 21. So the x must depends on your summation of your metric number. So dt. So you put 150 in front of the integration. Okay. Then you can get the answers for the term insurance. Okay, the second one is 50,000 for the pure endowment. So 50,000. Okay, so for pure endowment, we don't have to integrate. It is Vn and Px. So 50 Vn, what is Vn? It's E negative delta n. So delta is 0.05. What is n? N is 20. So you times 20. So 20p, 21. So the TPX for De Mor's law is, the TPX for De Mor's law is omega minus x minus t over omega minus x. So De Mor's law, mu x plus t is 1 over omega minus x minus t. That's why when we sum up the TPX and we multiply the TPX with the mu x plus t, we get 1 over omega minus x. We cancel out the omega minus x minus t. So now we only need the TPX. We don't need the mu x plus t. So it is here. So omega is 110, x is 21, t is 20, t and n you can use, it's the same, t and n. So we can use t or n. So omega minus x is minus 21. So you can solve this problem. So we don't have to integrate for the pure endowment. Remember, we don't have to integrate. No integration for pure endowment. Why? Because we pay for the survival benefit. So we put the exact age where after age 20, if he still survive, he will get the benefit. But for the death case, we put like if he die within the 20 years, we don't know when, within the 20 years we will pay him the death benefit. That's why we need the integration, because we have the interval period. And then for the endowment, so you plus both values from this and this, and you will get the endowment. Okay. And question 4. I have to go fast. We have only 30 more minutes. All right. So for question 4, for whole life insurance on X, so now we need whole life insurance. A death benefit are payable at the moment of death. So you know that it is continuous. So this is the keywords for continuous. So if continuous, it involves with integration. So the death benefit at time t is BT is equal to E 0.02T. So difference from previous question. Previous question, the benefit is constant value. We have 150,000, we have 50,000. So now we have function. So it's not constant. Okay. We have mu x plus t delta, and now you have to calculate the variance. Okay, so I just give you. Okay, so for question 4, first, you need to write the right notation. So whole life insurance is AX. So AX, so X is not given, so you can just write X. So the keyword here is mu x plus t is equal to 0.04 for all t, meaning that it is constant. The force of mortality is constant. We know that we have to use constant force. Remember, we have two types of law. We have De Morph's law, and also we have constant force. In question 3, we need to use De Morph's law. In question 4, it states that the mu is constant, is equal to 0.04 for all t, meaning that it is constant. It's constant force of mortality, so we need to use constant force. So for constant force, the TPX mu x plus t is E negative mu t times mu, because mu is constant. Okay. The TPX is E negative 0 to t mu x plus t dt. We have to integrate the mu. Since the constant force, the mu is constant, so we don't need to integrate. We just put the mu straight away. So for the life, for the constant force, the upper bound must until 0 to infinity. But whole life for De Morph's law, the upper bound is omega minus x. But for the constant force, the upper bound is 0 to infinity. Okay. So you know that we have to integrate the VT TPS minus plus T. So VT is E 0.060. So TPX is E negative mu T. Mu is 0.04. And mu is 0.04 dt. So you have to integrate this, and you will get the values. So now you need the variance. So you know that the variance is equal to 2 minus. So we need to find, meaning that for this one, we need to use E negative 2 delta T. Instead of delta T, we need to use 2 delta T. And the rest is just the same. And this is 0.04 T. So the difference only at the VT, because the VT now we have to use E negative 2 delta T. So here we will get 0.5, and here we will get 0.2857. So to find the variance, so you just plug in 0.2857 minus 0.5, scrap. And the answer would be 0.03557. I forgot to put the one more thing. You have to put the benefit inside the function because the benefit is not constant. Normally, benefit is constant, so we put outside the integration. But now the benefit is not constant and it has function, so we have to integrate together. So also here, so the benefit must be inside the integration. Okay, sorry